cooking? Yep. Oh, I have one more really important thing to do. Let's see if I won my fantasy football game. It was a barn burner. Came to last night, it was just kickers. My kicker versus his kicker.
I lost by 4.
So it's this week. There's my kicker. Oh man, I killed him. The guy I was playing, I don't know. He's a friend of mine, but I don't. I mean, well, he's a friend of a friend, so I don't really know him. Man, my kicker got 11 points. Represent. All right. I can't show it on here because my team name is questionable. I change it every year, and every year it's questionable. Actually, this year it would require some research to find out why it's questionable. Okay, so let's. Here, I'll just start way back here. Okay, so we're going to go through. Like I said, the exam is going to be about 10 questions. It'll be on Thursday. You'll have the full hour and 15 minutes to take it. My intention is for it not to be a time pressure issue. So if it is a time pressure issue for you, that probably means that you're not quite where you need to be in terms of being able to write code or problem solve, that kind of stuff. So I'm asking questions that should be easy enough for you to solve comfortably within an hour and 15 minutes. But I would guess that several of you might find that that's not the case. Remember, I do have the policy that if you do better in the final than you do in the midterm, I'll replace your midterm grade with whatever you get in the final. So nobody, well, I mean, I should say nobody should have to drop after the midterm. You know, one thing I do, one question I do deal with some people in my office is computer science is not necessarily for everyone. So with that in mind, I don't believe there's really stupid people. I think sometimes you make poor decisions as to what your major is. So if you are really struggling in here and it's not fun for you, like the challenge isn't fun, you know, there should be an aspect of it that you should feel like, okay, I suck at this, but I'm going to get better, and that's exciting. Kind of like when you play a sport or a video game or something like that. But if it's literally torture, it's like, I'm not interested in this. You know, then you might want to kind of reevaluate before you get too deep, you know, into the into college, where you're kind of in one of those situations where it's like, well, I can't switch majors now, or it costs me an extra year of school or something like that. At this point, you've had mostly gen eds and a couple of CS classes sprinkled in there. So so I wouldn't necessarily encourage anybody to drop if they do poorly on the midterm, but do try to self-evaluate as to whether or not you did poorly just because you're either A, not putting enough time in, B, just a little bit slow to learn the stuff, which is pretty normal. I mean, that's something I keep telling people come to my office. It is very normal to feel like you suck at programming for a long time until one day you've made enough mistakes and learned enough things that something just clicks and you feel like, you know what, I'm not all that bad. And then things usually go a lot smoother after that. So it does one day just kind of click, similar to a sport, I would think, where some point in time you just decide, you know, I don't suck as bad as I used to. You know, I'm not playing in the NBA. Yeah, I'm not playing in the NBA anytime soon, or whatever the equivalent is for throwing rocks. But oh, it's discus? I thought it was Olympics. Oh, that's you got every 4 years you get to go and suck. You probably need to go to a different country though. I mean, you probably couldn't make. You do shot put or discus, or what do you do? Yeah, whatever, the throwing crap, right? All right, so I mean, you probably wouldn't make the American team for that. Like, I feel we probably have good athletes for that stuff. Yeah. So I mean, you would have to go to like some made-up country. Huh? Yeah, they probably don't even have a rock throwing team. You could be theirs. Just declare citizenship. They'll take anybody probably. I bet you Lithuania has some good teams. Their basketball team's good. And I mean, I don't think you're up to that. You're not Lithuanian material. No, but that might be true. But you're going to want to keep that on the down low. You're going to want to find some heritage from generations. Somewhere in there, you're, I don't know, Taiwanese or something like that. I mean, something else, right? Oh, that's probably true. Yes, I mean that's your in. Yeah. So in any case, rather than trying to fake being a good athlete, believe that programming is one of those things you have to struggle with, and eventually it just clicks. I promise you, I've been doing this for a while. All right, but do look yourself in the mirror after the midterm. I mean, there's going to be some of you that leave the class after the midterm and feel like, okay, did I earn points? It could happen. I mean, so pretty commonly, the class average on my exams is somewhere in that 70, 75% range, but there might be very few people that get 70 or 75. You're going to have people that get 90 plus, and then people that get close to single digits. Because there's not like, I'm sort of okay at it, right? There's like, I'm pretty much where I need to be, or I'm nowhere close. That's where I say there's like some switch that clicks here in the middle where you're either clueless or you pretty much know what's going on. You made a stupid mistake or something like that. And I tend to not take off a lot of points for obvious competence. That was just a dumb mistake during the exam, but I tend to take off a lot of points for obvious incompetence. Like you don't get a point for writing the word int, when it was somewhere in the solution, just because you randomly wrote down every word you knew about programming. It's like, I'll put a semicolon here and an int, a couple curly braces, and there's got to be a couple points in there. So my exams are typically graded on competence, so it's you either pretty much know what you're doing or you pretty much don't. All right, so in any case, let's go through here. I'm going to highlight which slides I think are important relative to the final and which ones you could potentially gloss over. I'm not necessarily going to tell you what will and won't be because I haven't written the exam yet, but I'm going to go through this the same way I would go through it when I do write the exam later on today or something like that. So you'll get my reaction as to whether I think this is a legit topic or a non-legit topic. All right, so primitive versus object types, that's something I've asked in class a bunch of times. It wouldn't be super high up on my priority list, but if I needed a filler question, this would definitely be on the list of possible filler questions. Okay, so I think this is a really important concept to know. Several different times in class, I've asked that question, what's the difference between a primitive type and an object type? Primitive types can only hold a value. Object types can potentially hold a value and then also potentially do more. They can have methods and stuff like that associated with them. Primitive types are also typically built into the language. So our primitive types are byte, short, int, char, float, double, Boolean. All right? So history of our languages, I won't ask you to like draw this or anything like that. I guess it's possible that a question might ask you something that you might choose to reference back to where the language came from. Like, oh, well, it works this way because this came from C or C++, something like that. But this would be more of a trivia type of slide, just knowledge-based stuff as opposed to something I'd test you on. So I probably wouldn't worry too much about that. As far as primitive types go, I might ask you to list all the primitive types. I think that would be reasonable. I do expect you to have a clue on the number of bits and stuff like that, but I probably wouldn't ask that on an exam. That's more of I don't want you to spend your time memorizing this slide. That's what I'm getting at. Understand what the primitive types are. I think you should be able to list all the primitives, but I probably won't ask you what's the size of an int, something like that, even though I probably expect you to have a clue that ints are kind of plus or minus 2 billion, stuff like that, or the number of bits. I won't ask you on an exam. That's just extraneous material that you don't need the stress of having to memorize that. Unicode versus ASCII would be a fair question. I can't I would be surprised if that makes it onto the exam. I have other filler questions that would come in because I want to ask a fair number of programming questions. And then you have like the filler questions that just help you earn points. I would put primitives above this. Again, important concept, but I probably won't ask it. There will very likely be one conversion question on the test. I like conversion questions. So convert between binary and something else, or you know, hex, whatever, just some conversion question. And if there isn't one on there, it's because I forgot, because I tend to like putting those on like basically every exam I give, regardless of the topic of the course. Because you pretty much learn that early on, and that's something that is important for you to know throughout. So expect that. Obviously, this is important, the concept of Boolean expressions, because we use them for everything. I can't imagine asking a question like, what's a Boolean expression? That's one of those things I ask in class pretty often, but I don't think I'd waste a question on an exam for you to answer that. But, I mean, they're obviously integral to, you know, conditionals and loops and all those things. So you need to understand Boolean expressions, but I won't ask you a direct question only about Boolean expressions. Same thing with the Boolean operators. You should be able to use those programmatically, write Boolean expressions for conditionals, that kind of stuff. But I wouldn't ask you to list the Boolean operators or, you know, tell me how they work. You know, or these bitwise ones. Those are more trivia stuff. Yeah, so there won't be a bitwise question on the exam. You know, important concept in the giant sea of computer science stuff, but in terms of what we're supposed to come out of this class with, insignificant. These all fall into that same category. The shift stuff similarly, same category. Certainly understand variables. I could see maybe having a kind of a mini filler question like, you know, define an array that could hold 10 integers, something like that. You know, asking you to write that line like, you know, int array AR is equal to new int array 10, that type of thing. You know, just coming up with that line for defining a variable that does something, or maybe a couple of lines of code that manipulate something like that, as opposed to a larger, you know, write a method that does something. So in the big scheme of things on the exam, there will probably be, you know, a couple of questions that have you write something full. You know, write a method that does some logic. Then there'll be a couple of questions that ask you to write, you know, a couple of lines of code that does, you know, changes something, right? Maybe has you build a new string, or has you, you know, get the, you know, the second occurrence of L in the string hello or something like that, you know, so you'd have to use char at and show me that you understand that it starts at bucket 0 and, you know, that stuff. So there'll be programming questions like that that are much shorter, but still show that you kind of understand the, you know, the fundamentals of kind of what you're working with. So not every programming question is going to be, you know, solve a complex problem, because right now for most of you, when I ask you to write a method to do something, you know, something more than just like print a string or something like that, that's going to take some time because you're kind of pulling all your logic out there. That's not something you can do real quickly yet. So if I need you to finish this in an hour and 15 minutes, I can't ask too many of those. So there'll probably be maybe one more complicated one of those, like one, you know, mind bender, and then one kind of easier one that all of you should be able to do, kind of giving you your baseline, and then the other one should be much less code, but still programming, right? You know, well, it's actually an excellent question. I fairly often do that. So I could see, again, this will be a memory thing, whether I remember to do it at the test or whether I need an extra question, but it would be totally fair game for there to be a question to write an error-free hello world program. And that's going to be graded in binary. So it's either completely right or completely wrong. Now, I have been known to show some mercy given test anxiety, where if you forget a semicolon or something like that, yeah, I might put a little smiley face and not take a point off, or not take all the points off.
Turn the semicolon, sideways and turn the like put that there where they missed it.
Where they missed it. So I might show slight mercy in ways, but if you're like missing huge constructs, or if it doesn't look like a Hello World program, like you have int in there and curly, just a massive, like you've drawn a teenage, well, actually, if you draw a Teenage Mutant Ninja Turtle out of curly braces, that might be worth points. So if you're clueless, you might want to go that route. I'm a fan of Teenage Mutant Ninja Turtles. Did I tell you my wife got me these big stickers? There's like a company that makes these giant stickers. Fatheads, yeah, those. She got me Fathead Teenage Mutant Ninja Turtle stickers, so I wanted to put them up in the living room. Where does she want me to put these?
In the garage, probably. Simulator.
Maybe. No. Any place that people can come in and see our house, she doesn't. I'm not allowed to.
On the ceiling of your bedrooms when you're laying down.
I thought you were going someplace else with that one. Thank you.
How outside of the garage or?
Well, I could put it in the garage, my golf simulator, like he suggested. I think she's given up on that part of the house.
Outside, some people driving, they can see it.
Oh, yeah. I wonder how waterproof they are. Will they just stick to my boat or to her car?
They're like good enough that you can peel them up and put them in place. That's my experience.
Okay. Hey, well, actually, you guys... Well, I still have my company. I sold my company in 2014. Did any of you ever see my vehicle that had awesome fat logos all over it? Yeah, I should have find a picture of that somewhere. My wife used to always be embarrassed to ride in that.
But,
the Fatmobile.
I mean, well, it's still October. I'd put them on the side of your house and say it's Halloween decorations.
She might go for that, but then they have to come down. Why would she buy them for me if she won't let me put them up?
Are they the life-size ones?
I don't know. They're still in the package. She won't let me open it. Are they expensive?
I don't know.
$30? She spent $30 on those stickers and won't let me use them?
If they're the life-size, they're like $30 each. So if you got all four, that's $120.
Well, if she did that, I hope she got Donatello.
Is he your favorite?
Probably.
You can get that up yourself. You can make that up yourself.
Really?
You just Photoshop that you cut yourself around.
I wonder if they like charge extra, like for the extra material. I'm kind of like two people.
Mine, like, oh yeah, the printer wasn't tall enough. Like, the sheets weren't long enough, so like, I just cut off right here.
They had to give you a second applicator. Here's the other half of your face.
We were at the Brookfield Zoo in Chicago, my girlfriend and I, last summer. You know how they have like, oh, take a picture with the gorilla and like on the green screen, they'll Photoshop a gorilla. Like a person, not like a stand. So we can chop my head right off.
Probably nobody noticed.
I noticed right away.
What?
My head was gone.
Yeah, but nobody else noticed probably.
And then they asked if we wanted to buy it. I'm like, whoa.
What do you mean?
Is this 50% off like my head?
Did I tell you when we went to Israel this summer that they had in the old city, they had like the things where you could take your picture with an Israeli soldier? Did I tell you that in here? You know how like in Disney World you can go up to like a princess thing and put your face in the thing and have your yeah, so they have those in the old city of Jerusalem. You know, like a holy place, right? Where you can pose with and put your face in there as a Israeli soldier holding an assault rifle. Isn't that weird? There will be pictures in December of me at this is related to princesses actually. We're going on a Disney cruise with my nephews, and apparently I'm signed up. I just got the itinerary. My wife and I are signed up for a couple of different meet and greets with princesses. I guess that's a thing on Disney cruises. So I'll have pictures with princesses and probably Mr. Gonzalez, I assume. Because, I mean, he should be allowed to be in the pictures if there's princesses. Right? It doesn't make sense. He got left behind 2 weekends ago. Yeah, Mr. Gonzalez is the little doll I have that I bring with me to some places. So we took him to a restaurant for breakfast. I meet a couple of students on Saturday mornings for breakfast. And we left him there by accident. So we had to come back. And they had him by the front desk, like where the register is. basically as a greeter. Okay, so they had two straws, like crisscrossing on his back to hold him up, because he's like an elf on the shelf guy. And yeah, so they had him as greeting people. He had a good day. My wife put a post out with a picture of him saying something like that. He had a traumatic day and he needed some prayers. And he smells like French fries and dish soap, and he's not saying a whole lot, something like that. So in any case, you should be able to write variables. Only in my classes. Obviously, conditionals, you should be able to write those as well. I could see in a question, like one of the shorter questions, I might say, like, write a conditional that, or define a couple of variables and then write a conditional that is true under a certain circumstance. So instead of writing a full big logic method or something like that, just writing a single conditional that shows me that you understand how that kind of works. Same thing with loops. I mean, you obviously need to be able to do variables, conditionals, and loops. This goes back to the very beginning. You know, how do human beings solve problems? We use our memory, we ask questions, and we use repetition. So all programming languages give us those three things. That could make it onto the exam if I need a filler question, but hopefully that's ingrained in your soul at this point. So if I were betting, I would say that question in its natural form won't be on there, like how do human beings solve problems. But those three individual magic tricks, if you will, are important. Be able to create variables, be able to write conditionals, be able to write loops. And then it's a matter of taking those Legos and putting them together in a nice order to solve problems. Okay? The concept between a pre-check and a post-check loop, important, but I probably won't ask the question. I can't imagine having a filler question for, what's the difference between a do-while loop and a for loop or a while loop. Do-while loops are post-check, where the body of the loop executes once and then the question's asked. The other two are pre-check, where we ask the Boolean expression, the Boolean question first before we even execute the body of the loop once. Important. Less than a 10% chance that makes it on the exam, but I can't imagine that being a high priority question. Nothing with command line interface stuff. We've looked at how to compile a Java program from the command line. I want you to appreciate that stuff. I'm not going to, that won't be a test question. I could see this isn't a high chance, but higher chance than the pre-check versus post-check. What is compiling? Compiling is conversion between a high-level language and a low-level language. I'm going to call that a 20% chance being on the exam. So in the pecking order of low-priority questions, this would be higher than pre-check and post-check. Okay, understanding what compiling actually does. So this is important, but if I were to ask a question related to this, it would probably be with compiling. The idea of high level versus low level, that was really more of a 200 question. Let's call it fair game, but low. I have to get desperate. I usually can come up with something ahead of that kind of stuff. Scopes will almost definitely be on the test in some form. Really important concept. We've talked about it lots of times in here. So make sure you understand the idea of, there being a global scope, and then there's a scope relative to main. And so each one of our methods gets their own scope, and that for loops are kind of a special case where they get their own scope, but the other loops don't really get that. So understand the concept of scopes. All right, that almost definitely will be on the test in at least one question, possibly more. All right, again, this rule of thumb is important. I don't know if I'll ask something directly to this, but this is something we've mentioned in class many times, that variables always resolve to their most local definition. So that goes hand in hand with the whole scope thing. A question related to this, I know I'm jumping ahead a little bit, but if we're just kind of keeping in context, I almost guarantee I'll have some question related to the this keyword. So for example, I might have you write a constructor, or I might give you a pre-written partial constructor that takes 2 parameters in and ask you to set the fields. And then you'll have to show me you understand how to use the this keyword, something like that. All right, so this keyword, we're going to call that a 90% chance that's on there. That's a really important concept. Arrays are going to make it on there one way or another. It might be one of the questions. Typically on an exam, the types of questions I like asking for the programming ones are either string manipulation or array manipulation. Something that's going to kind of make you do a loop, move things around inside of some sort of construct like an array or like a string. So either build a new string, show me that you understand that to make a change to a string is going to require you to build new strings. Making a change to an array. Arrays are read and write, so we can access individual buckets of them. So I think there's a pretty high chance that the programming questions are going to involve strings or arrays. Those tend to be good fits for exams and are easy enough to wrap your mind around as opposed to sitting there for 15 minutes trying to understand the question I'm asking. Make sense? So I would, I'm not promising that, but I'm going to call that 85% chance, just based on the questions I've historically kind of come up with for the programming ones. So if you're studying programming kind of in preparation for the exam, string manipulation and array manipulation are probably your go-to moves. So I might like have you write a method that takes a number in and like counts the number of occurrences of that number inside of an array. Something like that. That kind of question that forces you to write a loop that goes through every bucket of the array, asks a question at each individual element in the array. Does this number match this number? If yes, increment a counter. That kind of stuff. So that's the type of question you should expect for the programming questions. I probably won't ask anything about the virtual machine. Important, but not exam worthy in terms of what I want you to show me you understand. Certainly the idea of contiguous memory related to arrays, that's important. So this is a fancy way of saying memory in a row. So I might ask you to explain why contiguous memory is important to arrays or how contiguous memory makes arrays fast. So that's, the idea of that is it computes off the base address of the array. So when we create an array using the new keyword, and by the way, there's a pretty high chance the new keyword makes it onto the exam one way or another. So similar to me saying the this keyword, those come up often in class, right? So you could use that as kind of a template. Things that I tend to keep bringing up in class over and over and over and over again, those find a way to make it on the exam. All right. Yeah, so the idea of contiguous memory where an array gets a base address and then like bucket 3 off that is the base address plus 3 times the size of whatever you're storing. So you're able to compute where bucket 3 of the array lives and instantly go there rather than having to jump through memory to memory to memory to get to the place, which is our linked list that we'll talk about in detail next semester, but I think we talked about it a little bit in here. So really this slide is pretty important as it relates to arrays. Any questions about array stuff? I guess I'll circle back. Let me finish going through the stuff, and then if you have things you want me to review, I will. New keyword will be on there, one way or another. I don't know how I'll ask it, but real estate agent gets us a memory address, used with constructors for our objects, used with arrays to build arrays, which is effectively a constructor, right? So, important. The idea of pointers is important, but I probably won't ask you a direct question related to them. That doesn't mean that you won't have to indirectly understand pointers, maybe having a method that takes in an array and copies all the contents of one array to another or something like that. You'll have to understand that arrays are passed by reference versus passed by value. understand that difference as well. What it means to be passed by reference, where an address is passed in and changes have side effect, versus passed by value, where changes don't have side effect. Again, it might not be me asking that question directly like that. Could be. But that concept will likely be represented on the exam one way or another. Okay, but I very likely won't ask you a direct question like, what's a pointer? All right. Automatic garbage collection, important concept, but I probably won't waste a question on it on the exam. And along the lines of that whole idea of a pointer count, probably wouldn't ask that either. Fair game, but I'm going to call that less than a 10% chance. That idea that the automatic garbage collector will, reclaim memory for any variable that no longer has things pointing at it. Pointer count is 0. Technically, I can ask the question, but I think it's highly unlikely I would ask something related to that. I want the exam to be more practical than that. The idea of a blocking call, I think could make it on there. It's probably in that 25% chance range. If I'm looking for a filler type question, that's kind of non-programming, but I need to fill out like the 10 questions on the exam. Something like, what's the difference? What's a blocking call? Something like when we read something in from the user with scanner, and we say, please enter something, and we go to, input.next. That's blocking. That's waiting for the user to type something in and press enter before it can move ahead. Okay, that's a blocking call. So it prevents the program from continuing ahead. We didn't talk about asynchronous in here yet, right?
200 we did.
Right, I'm talking about from a practical sense. We didn't do, yeah. Okay, so I probably won't use the word synchronous in that. Or if I did, I would use it like this. I would say blocking or synchronous in parentheses to kind of get you zeroed in on that concept. So really what I would focus on with that is the idea that this line of code blocks us from moving to the next line. It forces us to wait while the user puts something in and presses enter. All right, so that could be on there in some form, but I would say it's a relatively low priority thing for me to ask directly. You'll have to write a method on the exam. So 100% chance, 1 or 2 of the programming questions will be write a method that does something. I probably wouldn't have you write a full program unless we did the hello world question. Most of that's just space and time, but a method would be kind of fair game. Show me that you can write the correct method header, return type, name of the method, parameters, and then show me that you can put some logic together. So that's what all those guys were right there. Here we came back to scope again. We reintroduced it again when we started talking about the scopes related to methods themselves. So obviously scopes are very important. This concept probably won't make it there in any sort of direct way, but we did talk about global variables and how traditionally they're thought of as being bad, but sometimes they're helpful. And we've kind of seen that in some of our homework assignments where, it's fairly helpful to define our scanner one time up top and then just use it in our 7 different methods rather than having to redefine it each time through. So there's some benefits to that. But this is more of an opinion type question. I think historically, this is a rule of thumb where today I think it's more of use the right tool for the job. So this likely won't make it onto the exam in any sort of direct way. And what I mean by that is if I did have you write something larger, I gave you kind of the structure for a full program and had you fill in some of the blanks. You would not lose points if you used a global variable versus a local variable as long as you used the variable correctly. So if you made a global static variable, you're going to have to show me that you understand that concept. Having said that, really, really, really high % chance that the idea between instance methods and class methods, static versus non-static, makes it onto the exam. So static means that the member is owned by the class, therefore we call it using the name of the class in which that member was defined, so either the field or the method. Non-static means it's owned by individual instances of the class. So you'd use an instance of the class to call it. So for instance, the char@at method for string is an instance method. It's a non-static method. So we use s.char@, s2.char@, an instance of string to call that instance method, that non-static method. Whereas most of our methods we've written in here so far have been static methods. So we've called them using the name of the class in which the method was defined. And we typically have been naming our classes driver. So driver dot, whatever the name of the method is. Make sense? Now along those lines, so that concept will definitely be on there. Not static versus non-static. Along those same lines, a concept that might make it on there is going to be related to the idea of a static versus a non-static context. I'm going to call that like the 25% category. Like, when do you have to use this dot versus you can just use it, or driver dot versus just use the name of the method. If you are in a static method, you are inside of a static context, therefore the name of the class you're in is assumed to be there. You don't have to use it. If you are in a instance method, a non-static context, this dot is assumed to be there. Therefore, you don't have to use it. But the rule of thumb is it's never wrong to use this dot. It's never wrong to use the class dot, driver dot, by most of our examples. All right, low chance that that will make it onto the test directly, but it's important, and that's certainly a higher, or that's in that 25% range versus the 10% range for importance for kind of filler questions. So understand the concept of a static versus a non-static context. Context meaning, where am I? You know, if I'm inside of a method, that's my context. Is this a non-static or is this a static context? What does that mean? Okay. So this was kind of us getting back to talking about things passed by reference versus passed by value. So again, understand that. Very likely, if that concept makes it onto the exam, it'll be on there in something along these lines, where like an array is passed into a method. I might show you some code and ask you what the output of it is. So, and in that, I might pass an array to a method, change the array, and then pass that same array into another method and ask you what the output will be, and you'll have to understand that the output has that the array has globally changed. Therefore, the second method will have the new version of the array as opposed to the old one. Something along those lines. Similarly, if I pass primitive types like an integer or a char into something and I change that and then I pass it into something else, that does not have side effect because those guys are passed by value. So we get a copy of those. So be able to tell me what the output will be, showing that you understand the difference being passed by reference versus passed by value. Make sense? Okay, so that's that dude. Certainly the string stuff. So, you know, be able to use char@, be able to use index of. Those are kind of inverses of each other. So the I can see if I have you write a method that does something to strings, probably length, char@, index of, and possibly dot equals, if I'm having you compare strings, are going to be kind of your go-to moves. Things like 2 uppercase, 2 lowercase, less important. I probably wouldn't have you do like case sensitive type stuff on an exam. That's more error checking type crap. But those are probably your 4 really important methods as they relate to strings. All right, so then we kind of give some more context into this idea of object types versus primitive types, where we started introducing our own objects. So we had a player object in here where a player object had, so a question related to this might be for you to label the parts of a class, an object. So I might have a couple of variables up top with maybe some lines next to it. Then I might have a constructor. Then I might have a couple of methods. You'll have to tell me that the guys up top are called fields. This guy's the constructor. These are instance methods, something like that. You know, understand that the members of a class are fields, constructors, and methods. Those are the guys that make up classes in Java. Also understand the concept of a class being a blueprint and an object or an instance of that being the actual object that was built using this blueprint. Okay, the difference is a class is like the blueprint for a house. You know, if you live in a neighborhood that has a whole bunch of houses that look the same, and then each of those houses that was built using that same blueprint are individual instances of that house. That make sense? So understand the difference between the blueprint itself and then objects created from that blueprint. Okay? And related to that from an earlier discussion in here would be this idea of methods being untapped resources. There's a point where we define a method, and then there's another place where we actually utilize that method. We are allowed to define 500 methods and never use them, right? So that has no impact on the output of our program except for the size of the compiled program, because you have all these methods that have been defined. All right, so there is a distinct difference between where you give the logic, here's my reusable chunk of code if I choose to use it, versus up here when we actually call upon that method, passing it some parameters. Make sense? So be able to differentiate between a method being defined and a method being called. And maybe, I don't know if I'd ask something specifically like this, but an example might be if I gave you a program and asked you what the output of this is, and I wrote a couple of methods on the bottom, and then I had some logic inside of main, but in that logic I never actually call those methods. I'm almost trying to trick you into telling me whether you understand that those methods don't get called. Even though I wrote them, I didn't call them because everything begins and ends with main. Main said, you know, do this, then this, then this, then this. And even though I spent time writing these couple of methods at the bottom, I never actually called upon them. Make sense? So they won't have an impact on the output of the program. So understand that concept. Difference between arrays and strings, that'll be on the exam in some form, probably maybe in the method. So big deal is strings are effectively character arrays. That's how they're implemented under the hood. But strings are read-only. If you want to modify a string, you have to rebuild it. There actually is a class in Java called String Builder that allows you to seemingly directly modify a string, but the reality is, under the hood, it's doing the rebuild the string thing. Okay, so strings are read-only, arrays are read-write. Strings are only characters, arrays are anything you can create variables of. Okay, and with those trade-offs comes conveniences. So since strings are always read-only and strings are always characters, they can have a bunch of built-in methods for them, right? That specifically work with characters, that specifically work with the idea that a string has a consistent length and that kind of stuff. Whereas arrays have far fewer things built into them because they're so flexible in what we can use them for. We can store integers, we can store chars, we can store any sort of object we might want to make. All those can go into an array. So array, there's no such thing as an array to uppercase, because we might not necessarily have characters in it. We might have player objects. And what does that mean to convert a player object to uppercase, right? So because they're more generic, we've lost some of our built-in conveniences. All right, so understand the difference between arrays and strings. Probably won't ask the question. It is one of my favorite words, but I'll call this less than 10%, the idea of what polymorphism is. So having more than one method with the same name but a different number and or type of parameters inside of a class. Important concept for us to know, but typically I don't like memorization type stuff for exams. You know, I want you to show me what you're capable of, not that you remembered some stupid word. All right. Having said that, because my exams, I mean, there won't be any like multiple choice or true false type stuff. My examples are mostly written. If there's a word you're grasping for when you're trying to explain something, you just can't come up with it, don't waste your time trying to come up with it. Just give me the quick little description of what you're trying to say. I'll remember the word. I won't take points off for you not remembering the word. I want you to show me what, again, it's a competence thing. Okay? Doesn't matter what words you've memorized. If you can do it, you know, it's fine. I used to be a tennis player, so in tennis you have different grips. You have like a Western grip, and who cares what they're called? You know, you hold the racket the way you're going to hold the racket, and that translates into whether you're a topspin player or a slice player. I don't care what you call it. You can show me that you understand a concept, make up a name for it, as far as I'm concerned. Okay? All right. Same thing, method overloading. Probably won't make it onto the exam because we really haven't gotten into inheritance yet. So I'll call this less than 2%. I have to get really desperate, so might as well call that a 0% chance. But the idea of having more than one method with the same name, so similar to polymorphism, but it's a cross. So we might have a human that then becomes a player, and a human might have a method that a player then overrides, you know, overloads, makes its own version of that method that's more specific to players than it was to humans, something like that. So that's more foreshadowing stuff. Like I said, this keyword, very important. Constructors, very important. So these are going to be your, you know, more getting into the object-oriented stuff, the stuff we've been working with more recently. Here's your class member stuff, fields, constructors, and methods. Public, private, protected. There could be a question dealing with protected would be out. I won't ask you anything about that because we're not there yet in context. But public versus private, that'd be that 25% category if I needed a, you know, a question related to something, or I had some code that I used private fields in, and then asked you to use that code to do something, making sure that you understand the concept that if it's a private field or a private method, you cannot access it outside of that class. So make sure you understand that concept of that locking down class members if they're private. Getters and setters, again, important. I might put this in maybe a 50% type category. If I'm looking for, you might have to write a method like this, but if I'm looking for a question like, you know, what are getters and setters related to objects in Java or something like that, asking you to explain to me the concept of having private fields and then having public methods that give you access, either read-only or read-write access to those private fields. Those are your getters and setters. On an exam, I would probably call them getters and setters. I might put mutators and accessors inside of parentheses, but I wouldn't throw mutators and accessors just as standalone words because they're kind of an old school type. Nobody uses them anymore, but it's more of a history thing. So I'll either not use these or I'll use them in parentheses next to getters and setters. So a setter is a mutator, a getter is an accessor. Okay? All right, so that is content for the exam. So we have a little bit of time left here, so questions for me? Anything you want me to review? Concepts that are loose in your mind that you want me to clarify? Got nothing? So everybody's going to get an A in this exam. What stuff do you struggle with the most? Just everything.
You see that first one where you have to put your name, but
sometimes you screw that up.
Yeah.
I had a student recently, unfortunately, kind of an upper division student, wrote me a message saying that they had problems with one of their homework assignments, and they said, anything having to do with logic, math, or computer science, they struggle with.
You're in the wrong major.
Yeah, that's kind of what I'm thinking. And this is what I was saying earlier. I mean, I believe that nobody is stupid, right? I mean, we all have talents. We all have God-given gifts, and we're good at different things. Now, maybe computer science isn't right for this person. I mean, they basically told me, right? This is probably one of those situations where, there are, I don't know if they're a junior or a senior, but in too deep. Financially, it doesn't make sense to switch majors, so I get it. I mean, that's unfortunate. That's the way the world works today. But, I mean, early on, that's why it's important for each of you, after this exam or something like that, to look yourself in the mirror and say, am I in the right place? Now, I don't want to lose majors, right? I want all of you to have fun with computer science, or if you if maybe CS traditional isn't the right fit, maybe IT makes more sense. The argument I usually make is that they're different sides of the same coin. One's not easier or harder than the other. In principle, for some of you, you might find different things easier or harder, but IT is 75% using what's been created, 25% creation. So that 25% is really where programming still is in existence in IT. In fact, my experience has been a lot of times the programming related to IT is in some ways harder because you're working with less, graphical stuff and things like that. You're doing a lot of embedded systems. But usually your programs are more utilitarian. Like, I need a program or a script that does this, 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 and this. Rather than in computer science, you might have a program that's providing a business utility to some place that has to be flexible for all sorts of different situations. So IT is 75% using what's been created, 25% creation. Computer science is 75% creation, 25% using what's been created. All right, so the creation obviously is going to be the programming stuff as our tool. All right, so but that doesn't mean that programming is computer science. So programming is the tool that we use to create, but we're basing what we create off of all these other concepts, artificial intelligence, operating systems, things like that. If you want to take it down to, like contract type work. We attach pieces of wood to each other with screws and nails and using hammers and screw guns, that kind of stuff. That's programming. Okay, the act of putting our problem solving together. Now, I'm somewhat handy. I can build little things, but I couldn't build I probably could build a house, and I could probably make it stand, but it would be one of those overbuild things, right? So I'm not qualified to build a house, but I can probably build something, small, like, a little deck in my boat or something like that, where you put some wood up this way, put some wood up there, screw it all together, and make sure it won't fall down, and you're good, right? Okay. So that is problem solving. So that's what computer science would be to us, not the act of actually screwing the wood together. Okay, that's programming, screwing the wood together. So don't get that confused. Okay? Programming is not computer science. It is a tool that we use. If you're in IT, you might use that tool less often or in different ways, or in more self-help ways. So my experience has been that IT professionals typically, they utilize programming to make their individual lives easier more often than not. Whereas a computer science person is using programming because their boss told them to. We need a program that does X, Y, Z. Now, having said that, one of my former students from, I guess, 14 years ago, something like that, he's an IT person who his boss gave him a program he has to write in Python that does some IT stuff, but it's not to make his life easier. Maybe it would, but it wasn't his choice to write it, and he's struggling with it. But the point is that don't go to IT to avoid programming. Go to IT to change the focus of maybe what you're working on. All right. So I'd encourage all of you to look yourself in the mirror, make sure that you're focusing in the right area of computer science, or if another major makes more sense. I want you all to stay. I want you all to be successful. But I also don't like failing people. I do kind of like failing people. I like failing people who deserve to fail, just because they didn't put in any effort. I don't like failing people who naturally work hard, and it's just not for them. That's the ones that suck, right? I love failing people who just don't show up and stuff like that, and then they try to appeal it. Oh, he's not failing. He's actually smart. He's smart. If only he showed up. Well, you're smart, right? You like to think so? I mean, kind of a half and half, programming and laundry. All right, any other questions? So exam, next class, you have the full time to take it. Closed notes, closed book. If you have any questions during the exam, don't guess, come up and ask me. I'll remind you that next class. I will see you then.